Good morning, good afternoon, everyone. Um, to forgive me, today is my first webinar on this iteration of Teams. Can everyone hear me? All right.
I can hear you.
You can hear me. I only see you two in the attendees list. Um,
Maybe you have to let people off of mute.
it could be, yes, let me try that.
Chat is turned off.
Maybe we could change that.
I'm saying that this person's organization is not allowed in.
Oh, okay. Jeanette, if you can hear me, I've started the meeting, but I'm not sure that I can see anybody yet. How do we let the attendees in?
Uh, they should be in. There's 24 people.
Okay.
Them now, but I'm not seeing them on the screen management tab, and I can't hear any of their audio. Is that completely normal?
Yes.
Okay, it is.
And Shiva is here. He wasn't a moderator, so that's why he's not showing up like us.
Okay, outstanding. All right, then. Well, since I've been reliably informed everyone can hear me, we'll go ahead and get started. Everyone, my name is Chris Kerr. I'm a project manager here at ENTRUST Solutions Group. I've been working in GIS for close to 15 years now, and I've been consulting on all of our regulatory software for almost as long as that. Um, I am part of the legacy G2 acquisition from a few years back, and I like to think I was able to pick up a lot of insider knowledge from Tracy Thorleyson. Well, he's here, who you've all probably met and know. I'm going to get through a couple other introductions here. Mike, we also have Mike Levy um, on the phone today. Mike, could you give us a bit about yourself?
Hey guys, Mike Levy came onto the team in February. The team being the ENTRUST Solutions Commercial Group, and we're supporting gas and liquids HCA, and also some new tools we're working on. And we're just here to make sure we support all your requests and needs, and develop the tools to support your needs.
Absolutely. So we also have some other folks from our development team on the line today, so I have them available if we need to phone a friend. So what are we all here for today? This is the beginning of a new series of quarterly webinars, not necessarily exclusively for the GasHCA tool, but really all of ENTRUST software offerings. Our goal, two things, just to try to give some free education to current licensees of the tool and maybe prospective future users. And also just to make sure that all of you are seen and appreciated for the good customers you are. So we're going to do these, as I said, quarterly. We are going to record them. With that, though, this is my first one, certainly. So try to grade me on a curve. The Q&A chat and the chat are open. So as we work through the presentation, go ahead and put your questions in, and we will address them towards the end of the presentation. So
I did turn on chat so people can put in the chat questions.
Okay, that makes sense.
Or the Q&A, either one.
Okay. I am going to go ahead and share my screen, and we will go ahead and begin the presentation. I get rid of Mike here too. Okay, so today we're going to start with an overview of the class location of the GasHCA Toolbox. We're going to talk about standard class location, and then we're going to talk about the SuperRoutes enhancement to the tool. So this is probably familiar ground for the majority of the folks on the phone, but for the sake of the recording, I think it's probably important to just show how the standard toolbox builds up to the tool or to our results. So with that, I'm going to hop into it. GasHCA. We're all familiar with what the GasHCA Toolbox is. GasHCA is part of ENTRUST regulatory compliance software suite, performs regulated gathering, class location, HCA, MCA 710s. Also addresses the latest 611A4 regulations, which is a release that's about to come out. Finally, it has a lot of time-aware modules that just help with change detection. Of course, the GasHCA tool is unique insofar as it is a series of Python modules that live natively in the ArcGIS Pro framework. When you open them, when you open the tools, they're in your geoprocessing tools, and you can open the scripts directly, or you can open the model builder master tools, where all the scripts are kind of stitched together in a logical order operations. Of course, the neat thing about this, if you do have the tool, if you own the tool, you can do whatever you want with it. So a lot of configurations you can make to match your O&M manuals. So moving on from there, at a very high level, most of the modules in the tool, in fact, all of them, including class, have pretty standard inputs that are required. Of course, we're going to need our centerline routes, so continuously measured single part routes. If you're going to be running HCA, you're going to need MUOP and nominal diameter. For our structures, class is going to require 2 structured inputs. So we're obviously going to need points or polygons representing our buildings intended for human occupancy. And for class, we're going to need points or polygons representing what we call qualifying areas, which matches the code in 192.5B32. Your required attribution on those polygons, you're going to need a unique identifier, you're going to need number of occupied units and number of building stories, which is important for class 4. Moving on from there, again, most of us are probably familiar with it, but these tools are highly configurable, and for class, certainly there's a lot of parameters which we're about to review here. So with that, let's move on to standard class. Just to refresh our memory, how does the class location tool work? Very simply, the tool does not perform a sliding mile calculation the way a draftsperson would at a table, which is dragging our sliding mile area over the center line. We actually accomplish this by a series of buffering exercises, which we'll describe here. So to build to a class location value, first thing the tool does is it says, okay, I want to begin to construct my sliding mile counts. So I'm going to buffer my center line by our 660-foot distance. I'm going to check for intersections of bios with that corridor. And then I'm going to buffer those in turn by 660 and use that to begin striking my center line to build up to our unit counts. Similarly, if we want to find our qualifying area class 3s, the tool makes a buffer of 100 yards or 300 feet. Looks for intersections of qualifying areas and buffers those in turn to get our direct class 3 areas. Our sliding mile algorithm in the tool is going to examine each buffered structure, and it constructs a sliding mile segment. With all those intersections, it's going to look upstream and downstream. And then your highest unit count is going to be what wins. So once you have your segments constructed, they're all dynamically segmented or self-intersected against each other. And what you end up with is your sliding mile counts. Qualifying structures and outside areas are going to be class 3 by default. And finally, after we have our sliding mile, our clustering rules are going to be applied. Clustering is a term, it is in code, but for the purposes of our tool, a cluster in this case is going to be that nice cluster polygon shape that we see here. So what the tool does is it takes your unclustered sliding mile output and then applies that cluster, and anything that falls outside your building clusters automatically falls back to class 1. So not new ground for the majority of folks on the phone. That's how the tool is working. I do have other slides in here defining what a cluster is for us. I don't think they're particularly germane necessarily for our presentation, but I will include them in the slide deck for those who aren't familiar with how our clustering rules are applied. So moving on to that, SuperRoutes, the meat of the presentation. Traditionally, gas operators conduct class location analysis on our routes, which we talked about earlier, which are going to be our continuous non-branching sections of pipe within a larger system. Generally, those routes are going to span from one compressor station to the next, which isolates them in terms of operating pressure and product flow. We have a couple of development partners in this tool, with DTE and Phillips 66, so I think some of them might be on the call today. We were presented with a kind of a unique problem here. As I understand it, I wasn't around for the conversation, but PHMSA had some questions about how class location results are actually calculated for pipeline routes where you have an artificial boundary where your pressure regime and product flow isn't actually changing. So in our small example here, we have this tiny 15.42 foot segment. There's nothing really disconnecting it from the pressure or product flow from all these other pipes. So, the idea is how are you building up to a sliding mile count for that segment? Traditionally, our tool has another function called proration, which you can act for these short segments where we uprate occupancy counts for that segment, and that's a method and it's acceptable. But for these super granular gathering systems and things of this nature, maybe it's not as appropriate. So that's the problem. How do we build up to a sliding mile count for this short little segment here? So since PHMSA seems to be suggesting that they want that sliding mile count or that sliding mile to apply, we have to figure out a way to do that. Here's the problem though. That small little route, if you think about it, if you were to sit again at the drafting table and try to figure this out, you would first have to start at your begin point of that short segment and then draw out as many ways as you could 1 mile out into the wider system. So that's what our tool is doing. The tool is going to, for that one succinct input route, it found 11 ways to trace out 1 mile out from that segment. In fact, more than that, since it's a computer, it had to trace out every route within the station too. So your resulting super routes are not necessarily a mile in length, but suffice it to say, for each small segment like that, the tool is going to have to trace out routes just like we see here to get to the wider system. So if we look at our graphic, here it went west, and there it went, there it went a little bit farther west, and here it went north, and here it went east, and so on. The input to the tool in this case is going to be your existing route network. So just the center lines you're already feeding the tool. At junctions between our routes, an artificial super route extending at least 1 mile in either direction beyond the junction is going to be generated. There are some parameters in the tool, which I don't really have described here, that address things like connectivity between center lines. There's a snapping tolerance. The tool will also honor your elevation values in your center line. So for instance, if you have crossing lines and one of the lines is at 3 feet and one's at 4 feet, the tool is not going to connect them. But if you don't have elevation enabled, then it's going to attempt to make routes because all it sees is a connection. So as soon as you have all of your super routes created, so each of these distinct routes, the tool is actually going to default back to just a regular class location run. And again, due to the iterative nature here, and it is a computer, it has to run class location on each one of those routes. Your BIHO unit counts for your super route is then going to be overlaid on the original short segment. So what you'll end up with is the super route with the highest BIHO count is going to be the one that wins. And if you can see in the graphic here, you're sliding. We have for these two succinct segments, those two original segments, we now have a sliding mile count, and we can see our associated super route that was created by the tool. So at the end of the day, now we have a defensible, as conservative as it possibly can be, sliding mile count for those small segments. Hope that's clear. We're going to hop into the data itself here momentarily, but again, any questions, please be adding them to the chat. Wrapping up on the slides. So why is this probably something you may want to experiment with? Well, the good news is you don't have to change your data at all. These in the release, in the version 4.1 release that's coming in the next few weeks here, you're going to see these tools present. You're going to see a new module called the class location with SuperRoutes. You'll have a few parameters which we will document, separately. But just feed this tool your regular data. So your regular centerline inputs, your regular bios, your regular qualifying areas. You might want to consider whether or not you're going to use prorating if you're already using it, or if you're not using it. You don't have to, your class breaks are going to be accurate. It's repeatable, and the outputs are going to be defensible. So all that great metadata that we all use to defend our tool runs is present there too. So we'll get into that. Some of the boogery parts about this, a con. The only real one is our computational processing time is necessarily going to be impacted. If we consider our original short segment, instead of one route that we run with proration, now we have to run the tool on 11 routes. And the tool has to construct the rest to begin with. So processing time heavily impacted. On the roadmap, the future versions of the GasHCA tool we're going to incorporate the Microsoft Azure environment for SuperRoutes processing. We're targeting Q4 2026 for that. So those of you who are Liquids HCA tools users, it'll be something like that. So we'll use Docker to make a machine image, and that'll go out encrypted to Azure. Azure will complete the processing for SuperRoutes, and then you'll download it and similarly to the way you do for Liquids now. So if you don't choose to go that way, you as an operator, you may want to consider performing class location incrementally as changes in your system are observed, rather than attempting to run a baseline on what may be a very complicated network. So maybe if you're going to run it that way, your class location calculations become operational rather than like running them annually. So we are available to help you think about some of these scenarios when you get the tool. So before we hop over to the data, I do want to just make everyone aware there's a webinar feedback survey QR code right here in the last slide. So with that, just to remind you again to go ahead and be posting your questions in the chat. I'm going to switch over to my GIS data, and we're going to look at that same case in the data itself. So here's our GIS data. Again, most of us on the phone are probably familiar with the outputs of the tool. For those of us that are not, what we have here is our class location corridor, which we talked about, our qualifying area corridor. We have our all our great structure buffers, which are going to attempt to render and might fight me because we're in teams. Our qualifying area buffers, and then we have our cluster buffers, which are turned on here. So, but with that, I'm just going to hop into it. So there is our 15-foot segment right here. This is our original input center line. Note the route ID of DD20. Okay. So the tool, after you execute, is going to draw out all these super routes. So I'm going to go ahead and use my select tool and select within the extent of that route. And we're going to open up our super routes center lines here. We see we have 19 selected. Keep in mind, these 19 selected, they're not necessarily each associated with that original input center line. So what we have to do is find our DD20AA route, source route. which we see here. So if we reselect those, what we're seeing is every center line or every route that the tool made for that small route. So if you go ahead and start highlighting these, you can see all the iterative ways the tool tried to make routes. So note some of these are not a mile in length. Again, that's just the it's a computer, so it has to trace as many ways as it can. So with that, we build up to our unclustered class or sliding mile again, which most of us should be familiar with. And then, of course, our clustering rules are applied. Turn those off and turn our structure clusters back on. So now that we have our class location segments, we can actually go in and we can prove, if we select those two segments, we can prove that the tool calculated appropriately. And I have the wrong table here. Give this just a second. So if we go all the way to the end of the table, our super route ID, what we're going to find is the super route in our super route center line that those two there, that short segment is actually associated with. So we'll hit apply. And if we zoom out here, we're going to see that tracing out to this neighborhood here is what gave us our highest unit count, and therefore our sliding mile count. That's it in a nutshell, everyone. It's not too much more complicated than that. That's the core logic for the tool. As we've noted in testing that obviously it gets a lot more complicated in this. We could perhaps get into some of those unique scenarios at another time, but yeah, that's what we have for you today. Kia, do we have any questions lined up yet?
Right now, we do not, but I know questions come after you sit on this and think about it for a while. So feel free to message us or email us with questions. And then another reminder for the feedback survey is in the chat.
Okay. Well, maybe in our last moments here, again, this is our first one, y'all. So I'd appreciate it if you were very candid, what you found useful, what you didn't find useful, what you would expect to see. That would be helpful to me. And again, just a final reminder, we will be releasing this SuperRoutes tool along with our 4.1 release probably towards the end of the month here. So look out for that. You'll be an official communication. Oh, okay. I think we do have a question in the chat.
Does it still?
Go ahead, Kia.
It says, does it still have the measures for the original routes and original route ID in the output?
Yeah. So let's look at that. Yes, your original measures for your original source center line and your segments are going to be there. So just like you're already familiar with. So if you need to go back and call on those, you certainly can. And then if you needed to get the actual super route, you could do a join or relate or something like that. Great. Questions?
Any questions outside SuperRoutes, Chris, that you get occasionally? You want to just kind of address here?
I think I've covered most of it. Most of my concerns is just, again, folks, the processing time is impacted here. So your strategies could be selecting subsets. You could do a spatial selection on your input center lines, and the tool is still going to draw For instance, Shiva, you can stop me if I'm going way off base here, but you can still go in and say you have your whole long network here and you don't want to bog the tool down, or you just want to do testing or something like that. You can still go in and select just a subset of routes. And those would be your input routes, but the tool is still going to trace out to the rest of your network. So you can kind of cut down on your processing time there. I guess the other things I would encourage everyone to be very aware of is snapping tolerances when you go to run the tool. Um, if you don't have good connectivity in your center lines, the tool is going to attempt to make it. So if you have infinitesimal gaps or something like that, maybe a foot is a good tolerance, maybe something less, maybe something more. And finally, just be very aware if you're going to enable elevation. In fact, probably can take a look at, yeah, probably we could take a look at those parameters, and maybe that'd be a good thing to look at as a group. Thank you, Mike, for putting that in there, by the way. That we had a new question in the chat. Oh, one more thing we've actually implemented. So we'll attempt to show it here if Pro is going to behave for us working with teams, but you're very free to use the SuperRoutes parameters from the base class location tool. If you choose to run class location with SuperRoutes, it actually is multi-core processing enabled. So you'll use up just about every processing core on your machine when you run this one. So, it's a attempt to increase or decrease your processing time. Just be aware, whatever you hit the go button using this tool, it's going to lock most of your machine's resources up. So here we go. So here's the configuration for it, y'all. This, again, you're not going to see too many changes from the regular class location parameters. We're already familiar with all of those, but in our SuperRoutes parameters here, we're going to say, do we want to create SuperRoutes? Yes or no. Do you want to include or exclude Z values when you're processing your SuperRoutes? And again, we gave our example of across like this. And then finally, what your snapping tolerance is going to be. So when you get it, I'd encourage you just to experiment, see what works. You're probably going to find out a lot about route connectivity in your system. So I think that's really all I wanted to cover today. So maybe give it another moment for questions here. Hi, Julian. Is there a reason you'd run the SuperRoutes tool but check create SuperRoutes off? No, that seems like a logical hold, doesn't it, Julian? I think it's just the parameter is left in there just by default for just so the user can see that they're going to run it, if that makes sense. So if you turn create SuperRoutes off, it's not going to do. You're not going to make SuperRoutes. And I'm pretty sure the multi-core processing functions are just related to SuperRoutes. So I don't think you're going to speed class up. But yep. And I appreciate you all giving me your acknowledgments. You can hear me. Maybe another moment for questions. Okay. Well, again, in closing, please be very candid in what you found useful. We are looking to engage with y'all a lot more than we have been doing since we came over to EN. So we're going to get back in that regular cadence. These presentations are not necessarily just for licensees of the tool. If you have other operators or other GIS folks who'd like to get their eye on this, I'm sure they're very welcome as well. So last thought, watch out for the new release in a few weeks. Brad. Yeah, get to that. Thank you, everybody. I appreciate your time today. Thank you. Bye-bye.